Welcome back, everybody. Today we're going to talk about section 11.2, the law of sines. Now, everything we've done in trig thus far has dealt with right triangles. That's been the bedrock of everything we've done up until now. However, we've never talked about what if we didn't have a right triangle, because all life is not built on right triangles. So let's say we had a triangle that was not a right triangle. All right, this is called an oblique triangle. All right, an oblique triangle is simply one that does not have a right angle. So instead of using our right triangle trigonometry, our SOHCAHTOA, our unit circle, we use something called the law of sines. Now, the law of sines is an extremely math-rich topic, such that it's going to be going to do the basics of the law of sines here in part 1, and then I will have a follow-up video with some of the more advanced or tricky parts that you need to look out for with the law of sines. All right? So the law of sines is the sine of angle A over side A is equal to the sine of angle B over side B, which again is equal to the sine of angle C over side C. And basically what you're going to do is you're going to set up proportions based on the information that you're given in order to get a missing side, a missing angle, or multiple missing sides, or multiple missing angles. All right, let's jump right in with a fairly straightforward example. So if I say angle A equals 45 degrees, angle B equals 60 degrees, and side B equals 47. 47 units, it doesn't matter. Quickly draw a sketch of my triangle. And 47. Remember, angle B and side B are across from each other. So then I have angle C and side C there. So the first thing I can do is I could say, well, I can get angle C, right? So let's say the question is find angle C and side A. All right. Angle C is going to be the easy one, because if I have 45 degrees plus 60 degrees plus angle C, it has to equal 180 degrees. All right. So 45 plus 60 is 105, plus C equals 180. So C equals 75 degrees. We can use concepts from our former class in geometry in an effort to get it now. So angle C, we could say, is 75 degrees. All right. And now we're going to try to find side A. All right. So we're going to use the law of sines. So I'm going to say that the sine of 45 degrees over side A. Now I'm going to use the ratio that I'm given. So I'm going to say the sine of 60 degrees over 47. And this is what I'm going to solve in order to get A. All right. So if I cross multiply and divide, I get, I'm going to do it down here just because I have a little bit more room. I have, well, I'll rewrite it. So sine of 45 degrees over side A equals the sine of 60 degrees over 47. So I'm going to cross multiply and divide, and I get 47 sine 45 degrees divided by sine 60 degrees equals side A. All right, so now typically with the law of sines, if your class allows calculators, you should use them. If your class does not allow calculators, you should check to see if any of these angle measures are on your unit circle. For example, sine of 45 and sine of 60 are both on the unit circle, so we can use those. All right, so we can say 47, and then the sine of 45 is square root of 2 over 2 divided by the sine of 60. Now, if you don't remember what the sine of 60 is, again, we can make a very quick triangle. 60 degrees, here's 30, this is 1/2, and radical 3 over 2, and the sine is radical 3 over 2. All right, and that equals A. So then I have 47 radical 2 over 2, and it's divided by radical 3 over 2, so times 2 over radical 3. So I'm going to cancel my 2's, and I get 47 radical 2 over radical 3. And I rationalize to finish it off, radical 3 over radical 3. So I get 47 radical 6 over 3. And again, if your class does not allow calculators, this would be your final answer. If your class does, and it asks you to go to a certain decimal place, you should do that as well. So if it asks you to round to the hundredths, round to the hundredths, and so on and so forth. All right. So one of the things we can use the law of sines for, like I said, is for real world problems. All right. All real world problems are not built on right triangles. So it's going to make it much more difficult to do if all we had was right triangles. So next, we're going to do a real world problem and use the law of sines. All right, so here's the problem. To measure the height of a mountain, a surveyor takes 2 sightings of the peak at a distance 900 meters apart on a direct line to the mountain. The first observation results in an angle of elevation of 47 degrees, and the second results in an angle of elevation of 35 degrees. If the transit used is 2 meters high, what is the height of the mountain? All right. So the first thing we're going to do is draw a picture. So I'm going to scroll up so I can get a little bit more room. Right. And I'm going to say that the first thing I'm going to do is draw a picture of what I see. Well, there's my mountain. Doesn't have to be an artistic picture, just a mathematically accurate picture. And there's the height of the mountain. And we need 2 sightings. So the first sighting goes down to here. Here's my little guy looking through my transit. And the angle is 47 degrees. And then we go back 900 meters. There's my guy. And he looks up to the top of the mountain. 35 degrees. So, the first thing I need to do is I need to figure some stuff out. So I know that this is 90, right? Because we're talking about a perpendicular line with the ground. All right. So the first thing I can do is I can figure out what that angle is, because I have 47 plus 90 plus C equals 180. All right, and through algebra, I can at angle C equals 43 degrees. All right. So now I know that angle. Now, what I'd really like to know is I'd really like to know what that little piece is. In order to find out that whole angle, I can use triangle 2 to say 35 degrees plus 90 degrees plus, I'll call it C2 equals 180 degrees. And I know that C2 equals 55 degrees. Therefore, I know that little green piece is 12. All right. So now I'm looking at that triangle. And I know that that angle is 12 degrees. So I have 12 degrees plus 35 degrees, right? I'm going to say plus O equals 180. Doing a little algebra, I can figure out that O equals 133 degrees, so that's 133. So I'm starting to fill in my picture just a little bit, just by doing a little bit of adding and subtracting. All right. So we still got to figure some stuff out, though. So what else are we going to figure out? I know, what do I know? I know lots of things. I know that sine of 12 over 900 equals the sine of 133. I'll call that C. All right. So let's see what we can figure out from here. So I know the sine of 12 degrees over 900 equals the sine of 133 degrees divided by C. And we're looking for that piece right now. Sine of 35 over 12, 133 over, okay. So now this is where we're going to probably have to use a calculator, but we're going to try to not use it at first. So I have 900 sine of 133 degrees, and we divide by sine of 12 degrees, and that equals C. And you are going to have to use a calculator to do this. I typically would round to the hundredths place. So if you put this into a calculator, make sure you are in degree mode. If your calculator has a mode, should be 3,165.86 and meters. Yeah, talking meters. All right. So now the last piece is, now that I know that this is 3,165.86, is I can do the sine of 35 equals the opposite, right? Because we have a 90-degree angle here, right? So I can use this nice big triangle. And I can go back and use my SOHCAHTOA. All right. So I can say the sine of 35 equals h over 3,165.86. So let's do that. The sine of 35 degrees equals my opposite, my h, over my hypotenuse, which is 3,165.86. So then we multiply 3,165.86 times the sine of 35 degrees, and we say that that equals h. And if you do that multiplication, you can say the mountain is 1,815.86 meters tall. There's a lot of different ways you can do these types of problems. This is just one way. You might figure out a more direct route. That's fine. As long as you get the same number, that is fine with me. All right. All right, so this is just a quick introduction to the law of sines. Gives you some of the basics. You definitely need a lot of practice. The law of sines definitely takes practice, takes experience. In part 2, we'll talk about a little bit more about some of the more advanced things in the law of sines. One thing called the ambiguous case. And one way to do area of a triangle, which basically extends the law of sines to area formulas. So we'll do that as well. So thank you for listening. Like I said, more practice, and look forward to part 2. All right. I'll see you soon.